All right. Hello, everybody. Welcome to our summer CyLab seminar. We got some alliteration. This is recorded and on Zoom. Hi, Zoom people. And we'll be in the CyLab Partners portal. And so if you ask a question and you'd like to be picked up by the remote people or on the recording, please tap the microphone thing and it should blink green lights or something like that. So please do that. Welcome everyone. I am really excited to have our guest speaker today. Serge Egelman was one of my first PhD students here at CMU. I think he was actually the first one that I directly admitted, as opposed to they were people here who ended up being my students. So I've known Serge since 2004. And now we both feel really old. So Serge was always a lot of fun to have around as a student, and always a great person when we're having the conversation about what should we call the paper and we want creative ideas. Serge is full of them. So lots of fun. Also, when you travel to a conference and you want to know the best place to eat, always ask Serge. But he's also done a lot of really great research too. So we were doing a lot of work on anti-phishing research back in the day, and Serge was involved in a project on phishing warnings and how to get people to pay more attention to them. And then he went off and did an internship at Microsoft Research and talked to the browser team and showed them our work. And sure enough, the next version of their browser actually followed our advice on browser phishing warnings. So that was super cool. After graduating from CMU, Serge did a postdoc at Brown, and then he worked at NIST, the National Institute of Standards and Technology, for a while. And then he joined Berkeley in the International Computer Science Institute, ICSI. And he's done a lot of research on mobile apps and privacy, which we will hear about. He also started a company based on that research. He analyzes mobile apps for regulators and lawyers who want to sue companies and things like that. He has a lot of experience with lawsuits. His work is very much in
not as a defendant.
Not as a defendant. And he also has won a lot of recognition, including the Casper Boden Award for Outstanding Research in Privacy Enhancing Technologies, and the Spanish Data Protection Authority's Emilio Acid Personal Data Protection Research Award. So with that, Serge.
Thank you for the amazing introduction. It's fun to be back here. It's been a while. So what I was going to talk about today is basically the culmination of about 12 years of research now on mobile privacy. So jumping in the beginning was the word, and the word was permissions. So about 10 years ago, when I started looking at this, everyone was focused on permissions. When you install an Android app, the only real signal to users about any privacy implications, aside from privacy policies, which I'm going to get to in a little bit, were these install time warnings. And so we did a study where we looked at whether people are noticing these. We did a comprehension survey where we had Android users in the field. We advertised the study using in-app ads so that we knew they were actual Android users. And we found that, by and large, people didn't notice the install time permission requests and don't really understand what they do. Earth-shattering. Since then, things changed. So both major platforms shifted to these runtime warnings. These were an improvement because they have contextual information. The user is doing something when this warning is displayed, and then they can reason about what they were doing and whether or not this request is reasonable given that context. That's an improvement, but there's still a shortcoming in that it doesn't really identify how data will be used by the app. And so, even today I get this question about, from everyday users, how can I identify apps that have good privacy practices? And I tell them it's simple. Just do what we do, instrument the permission protected APIs, disassemble the app binaries, and then perform deep packet inspection. Done. But obviously that's ridiculous. And instead, though I contend that this isn't really any less ridiculous, what consumers are presented with is the notice and consent framework, which means reading privacy policies. And so let's take a look at that. So we want to pick an app from the App Store. This has actually gotten better. I retook this screenshot yesterday. Used to be that you'd have to scroll all the way to the bottom to figure out where the link to the privacy policy is. Now it's this column developer contact. I don't know why developer contact is the right heading for that, but anyway, you click that, you can read the privacy policy, and read it you will. So here's TikTok's privacy policy. There are about 5,000 words. It has a Flesch-Kincaid score of 36, which means that it's at the college reading level. Lori and Alicia McDonald did a study about this 15 years ago now, looking at the average number of websites examined by the average user, average reading levels, and the average length of the policy, and concluded that it would take about 200 hours a year for the average consumer to read all the privacy policies of the services they use. Obviously, during the proliferation of online services over the past 15 years, I would wager that this has gone up significantly, if for no other reason than just the number of websites visited. But I'm sure that the complexity of the privacy policies has probably also gone up. So this is ridiculous. But it also doesn't really help most people. So, one question that a lot of consumers ask is, what about third parties? What data is going to be shared with third parties? Who are those third parties? And how can I learn about their privacy policies? And so the app's privacy policy will often say data will be shared with third parties. This is ostensibly because those third parties have their own privacy policies, and so the curious consumer can then go find them. The problem is they're couched in terms of our service providers without actually naming those third parties. So here, this is actually an exception. It names both PayPal and Stripe, but the other third parties, it just says customer and technical support providers or researchers, advertisers, and it doesn't really tell you who those parties are, and so you can't really find their privacy policies. And so there's not really any way of getting from 1 to 2 here. Nonetheless, privacy policies are legally mandated for most online services these days. So for child-directed services, going back to 2000, there was a requirement that they post privacy policies. In California, starting in 2004, online services directed at California consumers required privacy policies. CCPA has a similar requirement, so now they're double plus required in California. GDPR also has a requirement that privacy notices be posted, but most of these don't actually have any requirements about naming the specific third parties. Certainly consumers under some of these laws can make access requests to the organizations to find out who data was shared with, but there's not a requirement that the privacy policy state the names of those third parties. And if you're making an access request, that's all happening, post hoc, after the data has already left your device and because you've engaged with the service. So over the past year or two, both major platforms have shifted to these privacy labels. And so these display the data types collected and also the purposes. So data to track you, data for advertising, and so forth. What people don't realize, though, is that these privacy labels are self-reported. They require the app developer to go to a website and fill out a questionnaire about their data practices. It's not like they're auto-generated through app testing. And so, the question that we had, are apps complying with these? Do they comply with their own privacy policies? Do they comply with applicable laws and regulations, or even the App Store policies? And so we set out to test a lot of this, starting about 6 or 7 years ago, as part of a bunch of user studies that my research group had been doing. So we had been surveying consumers about the apps they use and what their expectations are about the data that's collected, and we decided to augment this with ground truth data. And so we've been picking on Android for the past several years just because it's open source, which means that we can add our own instrumentation to it. And so we started around, I think 2014, 15, of instrumenting Android. We now maintain our own fork of it, which has this instrumentation, so we can automatically log whenever certain types of sensitive data get accessed. And then around this time, I started hanging out with the networking group at ICSI, and they had their own project called Lumen, which was a network traffic monitor that ran under Android. So we combined forces and then deployed a click farm, essentially. So we built an end-to-end system for testing apps. Do I have that? Yeah. So we collect apps, scraped from the the Play Store as well as various third-party repositories. We have a test bed of lots of phones that are running our instrumentation, both the platform level to look at what data gets accessed, as well as the network instrumentation to see what gets transmitted. And then there's a lot of personal information on the devices that we know a priori. And so we can then just scan for that automatically in the outgoing network traffic. And in some cases, the incoming too, as we've learned, there's some interesting findings there. So we can look at things like, what people think of as personal information, like the name of the user who owns the device, contacts, phone numbers, email addresses, as well as all sorts of persistent identifiers tied to the device. And so we run apps through the test bed. We have a database that basically stores the raw network traffic as well as the parsed results of what identifiers we found. And then we're exposing this through a website initially, and then an API that you can query against. And so using this, we've done a lot of studies over the past couple of years to look at privacy compliance at scale. So testing hundreds of thousands of apps. And here's an example of an interesting finding. So when we started to do this, a regulator asked, who are the biggest, what apps are sharing location data with the most third parties? And so this was an easy query to do in our database. And I found that the CVS app was sharing geolocation with like 40 some third parties. And this seemed weird. I ran into the student's office who had been maintaining the infrastructure and said, surely there's a bug. We need to look into this. But it was no bug. What was interesting was that the whole CVS app was basically a web view, and it would load all the content from CVS's website and put it in the web view. This web view was setting the user agent string, which is sent with every HTTP connection, but adding latitude and longitude coordinates to the user agent string for some reason that's still inexplicable. What this means, though, is that any third-party content that's loaded on those websites that were loaded within the web view would also get the user agent string, hence the location data. And so most of the third parties listed here probably had no idea that they were collecting location data, but nonetheless, it was flowing to their logs, and this is violating CVS's privacy policy. And so, I spent a couple of hours trying to find a security contact at CVS to report this to. And upon giving up, I just emailed the customer care email address, which was the only contact info that I could find. And of course, I got this delightful form response. I'm not even sure this is a form response, given the language and typos, but saying that they don't collect any location data at all or share it with third parties. And so having given up, we decided to actually just create a blog to blog about this. And this became the first post on the AppCensus blog, which we literally created just so that we could disclose this finding to get someone to pay attention to it. And so CNET picked it up, and then CVS was embarrassed and finally fixed it. So part of the issue, though, and this is sort of the theme of the whole talk, is that developers are often unaware of their app's privacy issues. And this can create legal liabilities. So if you're sharing data inadvertently with third parties and your privacy policy says you're not, or there are applicable laws that say that you need to make certain disclosures or not share certain types of data, this can get you in trouble. I mean, it's the type of thing that there are many plaintiffs' lawyers who are actively searching for these situations. So as a proof of concept, we decided to look at, to basically put our tools to use to audit compliance. Initially, we had talked about looking at privacy policies. And so it's funny, through this, I've sort of been recognized as an expert on children's policy and a children's advocate, but this came from a place near and dear to my heart, which is laziness. We didn't want to read privacy policies, and I'm of the opinion that multiple people reading the same privacy policy aren't necessarily going to agree what it says. They're vague and ambiguous, and so we decided let's compare the ground truth against statutory language. And so we chose the Children's Online Privacy Protection Act just because it's been a law that's it's been on the books for over 20 years now, since 2000. And there are several requirements that create nice heuristics that can easily be searched for in the data sets that we've collected. So there are prohibitions against collecting certain types of personal information. So for instance, names, email addresses, location data. So location data, particularly, the FTC exercises what's known as strict liability, in that it doesn't matter what the reason is. If you're collecting location data in a children's app without verifiable parental consent, that's a violation of the law. Behavioral advertising is also prohibited. To the extent that some of these things can be done, that requires verifiable parental consent, and the FTC has very strict guidelines as to what constitutes verifiable parental consent. And then any personal data that's collected, including persistent identifiers, needs to have reasonable security measures. And there's a lot of case law from prior FTC cases that's established TLS as a reasonable security measure. And so these are all things that we can easily check for. Here's an example. So here's an app that we scraped from the Play Store. This is quite clearly directed at kids. The name of the developer is Baby Bus Kids Games. But don't let that confuse you. There are many developers who have names like Baby Bus Kids Games who, in light of this research, have claimed that they don't target kids. So here's an example traffic dump from them. So in the yellow, it's showing that it was going to port 80 of talkingdata.net, which is an analytics provider. And in blue, that's a whole slew of persistent identifiers tied to the device, including the advertising ID, the device serial number, the IMEI. Green has nearby Wi-Fi hotspots and their MAC addresses. This is considered location data. And so this is very much illegal under COPPA. So we found as many kids apps as we could, and that amounted to a little under 6,000. We found evidence of violations in a majority of them. So things like outright personal information like GPS coordinates and email addresses, that was relatively fewer than the others, so about 5% of apps, but still like 1 in 20 apps. That's still a violation. Almost 40% were collecting non-resettable identifiers in violation of platform policies, which I'm going to get into in a bit. A little under 20% were sending data to services whose terms of service said, don't send us data from kids apps because we will use it for COPPA prohibited purposes. And then 40% of all the transmissions didn't use TLS. They were sent in the clear. So Google and Apple both have a policy where they have these advertising IDs. And so for advertising purposes, going back to about 2013, app developers are only supposed to collect this advertising ID for advertising or analytics purposes, and it's not supposed to appear alongside other identifiers. The reason for that is there are system settings that allow the user to reset that advertising ID. And so if the advertising ID is sent alongside other identifiers, that negates this reset feature and basically takes away any privacy-preserving capabilities. And so on the right here is Google's official policy that this requires explicit user consent if you combine the identifiers, which we've never actually seen requests for that consent in practice. Nonetheless, 75% of the apps that transmit the ad ID do so alongside other persistent identifiers, violating Google's terms. And this is sort of a pattern that both of the platforms have policies which seem, like they're good in terms of privacy, but those policies don't really get proactively enforced. And if the policy is not enforced, it doesn't really exist. But by and large, the apparent violations that we observe seem to be due to third-party services, so SDKs. And I want to be clear that third-party components are not inherently bad. Most of engineering relies on them. Your Volkswagen car has Bosch and Siemens components. Most complex engineering, the manufacturer doesn't make all of the components, and this is most advanced developed economies have known this. So specialization, the division of labor. Adam Smith wrote about this 300 years ago. But nonetheless, using third-party components requires some amount of due diligence. So almost 1 in 5 apps were using third-party components that explicitly said, do not use this component in child-directed apps. So here are a bunch. Many of these most consumers have probably never heard of before. But let's take a look at Mopub, which at the time was owned by Twitter. I think they sold it out as part of the Twitter fire sale that's been going on for the past couple months. So it says in their terms of service to developers that they don't collect information from children, and don't send us data if you're a child-directed app. And you might wonder why that is. Well, if you read their privacy policy, it's because they say that data that they get sent as part of Mopub advertising will be used for behavioral targeting, which would violate COPPA if that came from kids' apps. So we wrote a paper about this. It was fun. The New York Times covered it. There were a bunch of lawsuits. Everyone had a blast. They sent a photographer to ICSI who looked in my office and said, too many plants, not enough blinky lights. So we went to the machine room. This was my first time in the machine room at ICSI for the photo shoot. But after this, both platforms created new policies surrounding kids' apps, and these have still been evolving. So I think as of today, the policy for both platforms is that if it's a child-directed app, you're not allowed to collect any identifiers at this point. So part of this, Google, one of the requirements is, understanding that this is due to a lot of these third-party components. If you're a child-directed app, they now have a list of certified ad networks. So your app can only, if it does advertising, it can only use one of these certified ad networks. And that's because all of these have configuration options that allow them to be in a child-directed mode for COPPA compliance reasons. So developers can call a function to disable behavioral targeting when that SDK is bundled in children's apps. The problem is use of those configuration options is entirely self-certified by the developer, and there's no checking on behalf of the platform to see whether or not developers are actually doing that. And in developers' defense, it's not easy. So there are lots of different ways. So here's Ad Colony. It's one of the certified ones. It instructs developers that they need to check a box from within the dashboard. This is well buried in their support website. Here's another one, Chart Boost. Also, in their documentation, it instructs developers to check this box to opt out of behavioral targeting. The instructions don't say anything, about child-directed treatment. Only if you go through the support website do you figure out that this is what you're supposed to do if it's a child-directed app. Kachava, there's a snippet of code that they instruct developers to paste into their app. And so a little over a year later, we retested this again with about 6,000 apps, and we found that things had improved. So, collection of location information went from, about 1.5% from 5% before. Use of TLS also increased. So about 15% were not using TLS when it was 40% before. So that's better. But the issue about the unapproved ad networks and correctly configuring the configuration options is still a big issue. So, Mopub and Facebook say don't use our SDKs in child-directed apps, period. Nonetheless, Facebook anyway. What was that? Facebook anyway was, is pervasive. Kachava, we found none of the apps that were using Kachava had set the COPPA-related flags. And so, the problem is that each SDK has its own API and its own method for configuring this stuff. And so it's complex for developers to figure it out. But also supply chains can be complex as well. So, sometimes it's SDKs all the way down. So here's an example. Duolingo. We observed it was in the child-directed section of the Play Store. It's what's known as a mixed use.
Swap you out. Pardon the interruption.
Okay, hot spare.
Failure.
Yeah, that was good.
Thank you. Okay. You should be good.
Okay, and we're back. So Duolingo was sending data to Facebook as part of the ad APIs. So there was a flag labeled copy equals false, and it also sent the ad ID, which I've highlighted. And so this signals to Facebook that that ad ID can be used for behavioral advertising. So looking at this, Facebook's SDK documentation instructs developers to call this function set is child directed to true, and that manifests in the traffic as copy equals true. We weren't seeing that; we're seeing copy equals false. So we do what we call binary archaeology and decompile the app. So what we see here is certainly that method is being called set is child directed, but nonetheless, I guess it wasn't getting called. Looking back, we can see that this is actually being called by Google's ad mediation, which is another SDK. And so the Facebook SDK wasn't being called directly, but instead was called by Google's ad mediation SDK. For those not familiar, mediation SDKs, instead of having SDKs from every ad network bundled into the app, you can have a mediation SDK, which will contact multiple ad networks to optimize the ad revenue for the developer. So in this case, AdMob, which is owned by Google, was doing the ad mediation. And so, looking at the AdMob documentation, it says, oh, for COPPA compliance, simply call tag for child-directed treatment, which we also found in the code for Duolingo. So the core app code was calling that function. However, if you scroll to the bottom of Google's guidance, it says that if you use AdMob for mediation as opposed to as a standalone ad network, this function is just ignored. And if you're doing ad mediation, don't use AdMob. And so clearly what's happened here is some developer didn't scroll to the bottom to read that. They were calling the function, expecting that it was configured for COPPA compliant treatment. And instead, that function just gets ignored in that implementation. This has since been fixed by Google. And so I think you can use AdMob now for mediation. But this illustrates the problem. And so, the question is, do developers know to look for these documents? And more importantly, in large software engineering organization, do those responsible for compliance know to, request their developers to document all the SDKs that they're using and whether they've been configured correctly? So following this up, we also started looking at misuse of a lot of this stuff. So most of these issues that we found before were due to misconfigurations and likely just negligence on the behalf of developers who didn't really know what they were doing. We realized that we could use our same instrumentation to actually find malicious things. So we built a system then using our existing system to look at side and covert channels. And what I mean by side and covert channels, so a side channel, you have a security mechanism, in this case, the Android permission system, which prevents apps from accessing certain protected resources. If there's a pathway around the security mechanism, that's known as a side channel. Covert channel, maybe you have one app that has access to the data, another app that doesn't. If those apps then collude, you can bypass the security mechanism. And so we built a pipeline to automatically detect side and covert channels in this manner. Using our app testing data, we could look at what personal information was sent out, and then look at what personal information an app had access to via the permission system. And so let me give you an example of that. So you have two sets here, apps without location permissions, and then apps transmitting location data. How many of you think these sets are disjoint? That seems like it would be a reasonable assumption, yes? But we found over 1,300 apps that did not have location permissions, but were nonetheless transmitting location data, which was interesting. And so we wrote a paper on all of the different ways that the permission system was being bypassed. I'm still bitter about this. So the title was 50 Ways to Leak Your Data. And we spent so much time coming up with creative section headings, like look in proc. If for those familiar with the song, this is funny, I promise. But the chairs made us change it. Anyway, so the proc file system is a virtual file system. There's a lot of system information there. It's also it was totally unprotected, and so procnet ARP has the ARP table, which would list the MAC addresses of upstream routers, which the Wi-Fi router is a surrogate for location data. There are a lot of databases that map Wi-Fi router locations to Wi-Fi routers to locations. So here's an example of one SDK. So this is, again, more binary archaeology. It checks to see whether this permission is granted, and failing that, it jumps to this function, get device address from ARP. And then it opens a file handle to procnet ARP. After it has been denied, going through the normal Android API, it then goes and gets it the illicit way. And we found this is fairly common, particularly among location monetization SDKs. And so this was a whole industry for a while of SDKs that tell developers, monetize your app without showing ads. And the way they do this is surreptitiously collecting users' location data, augmenting that with persistent identifiers, and then selling that to data brokers. And these are in billions of billions of installs, as we found. They also violate, Google's terms of service and Apple's as well. It's just, again, it's not something that's proactively enforced. And so after disclosing this, things happened to a bunch of them. So OpenX was found in a bunch of children's apps, and so they got hit with fines under COPPA. And then others got kicked out of the Play Store, which was fun. So Huck and X Mode, again, I'm sure household names to everyone, right? But again, these impacted billions of people potentially. So moving on, so we found a bunch of these issues, and it's not clear whether developers understood that the SDKs that they're using in some cases were malicious, as well as we also wanted to understand the how developers make some of the configuration mishaps. And so we decided to put together this study on how developers learn about their compliance obligations and what processes they have in place to deal with them. We surveyed about 130 developers of kids apps. Again, the reason why we've been focusing on kids apps is this is a well-regulated space. So COPPA has been the law of the land in the US for over 20 years now. GDPR has its own provisions, which are substantially similar to COPPA. We followed up with interviews with about 30 of the developers. And then we also tested their apps to look at how their responses in the surveys and the interviews about their processes corresponded to the behaviors of their actual apps. We asked them questions about, are they aware of the privacy laws that govern their apps? Are they aware of their own app's privacy behaviors? And then how do they check their apps for compliance? So we started out with the awareness questions. We asked them about various privacy laws. 80% said they were familiar with COPPA and GDPR, and also said that they understood that their apps must comply with them. This seems good. But on the other hand, 25% they're familiar with FLRPA, which was an acronym we just made up. But only half said that they had processes for addressing the various laws, which is interesting. So 80% said that they're aware laws govern the apps. But there seems to be about 30% who are aware of the laws that govern the apps, but have no process in place to address them. And so one of the questions we ask is, why don't you obtain consent for data collection? And we asked this to all the developers whose apps were actually collecting data that would require consent under the laws. And there were a lot of misunderstandings about the role of the platform. So, some said that, because they put this in the privacy policy, they believe that that's all that they need to do to be compliant. One thing that kept coming up regularly, it was that many said that they, submitted the app to the Play Store. Google reviewed it and posted the app to make it available to consumers, and therefore they know that Google checked it and the app must be in compliance with the law because Google has approved it. And this was very common and scary because Google does no such compliance checking. There was also a lot of misunderstandings about their obligations as well as what SDKs do. So some said, oh, we only have analytics SDKs, and they only collect general data. like location, which is explicitly prohibited. There were other interesting, so here again, Google, routinely verifies respect of COPPA. Most of the compliance seems to be reactive. So most developers said that, they submit the app, and unless they get complaints or Google threatens them, to remove the app from the App Store, they don't consider the issue ever again. Another interesting one, we never collect any data from users. We always use AdMob for ads. Well, AdMob does behavioral advertising, which would be illegal without parental consent. Another response that was interesting was that, developers said, oh, they've gotten warnings from Google that their app is violating COPPA. And so they fixed it by just recategorizing it, moving it out of the child-directed section of the Play Store and moving it to the general audience one, which is not a solution under COPPA. So, for an app to be considered directed at children, it's based on the content of the app. And so just recategorizing it does not solve that problem. Half were unsure whether the data was encrypted. 72% were confident that their apps didn't send data to third parties, and more than a quarter of those were wrong about that. And again, most of these issues were caused by third-party SDKs, which is a thing that keeps coming up over and over again. So speaking of SDKs, this was another interesting finding. We found this SDK, which took a while to reverse engineer because it was sending encrypted. Everything was encrypted beyond on top of TLS, and also all string constants in the SDK were encrypted, including function names, which then got dynamically decrypted at runtime using a key derivation function based on a password that was embedded in the app. And so it's funny, they say we don't sacrifice your user's privacy or battery life, but they were doing 10,000 rounds of a key derivation function on a password that was embedded in the SDK, which is just wasting battery life. Anyway, after reversing it, we observed that it was sending clipboard contents, basically all the device identifiers, MAC addresses. So it was doing network broadcasts to fingerprint all the devices on the network, as well as email addresses, phone numbers, and location data. We ended up writing a blog about all the details. I highly recommend reading it. Anyway, we reached out to, I got a little cut out. Based on, the more we found, we were trying to figure out who owns this company, Measurement Systems, which was very opaque. It was registered to a company in the Caribbean, and there was a series of shell companies. One of them we figured out by doing, there was basically an OPSEC failure. We went through historical whois data and found that there was a period of time where there wasn't private registration on the domain, and the organization was Vostrom Holdings, which, oh yeah, so yeah, they also, the Wall Street Journal, another picture in the paper. My wife got a photo credit. They said the article wasn't long enough. Can we give them some photos to put in the article? So anyway, we traced through the series of holding companies alongside the Wall Street Journal reporters. That was fun, pretending to be an investigative journalist. But we basically found a series of different shell companies. And it was also tied to this company, Packet Forensics, who in 2010 was selling these devices that they claimed to subvert SSL. And a lot of people in the security community were wondering how in the world they were doing this on these boxes. Because it's probably not some 0-day against SSL. So looking at the whois data for who else was registered at one point by Vostrom Holdings, we found this whole list of other domains, including a fake law firm, which is interesting. One of the domains, TrustCore, is a certificate authority, and their roots were in all the major browsers and operating systems. And we figured out that it was a post office box at a Kinko's in Toronto, and it was also linked through shell companies to these other actors. It's still interesting. There's still so many unanswered questions about this. And so we successfully got a root CA kicked out of the browsers. So that was fun. Anyway, so supply chain issues. In this case, we discovered this because of this shady SDK measurement systems. And through the investigative journalists, they actually reached out to one of the developers who had bundled it, and the developer was willing to talk off the record. And basically shared emails that showed that the company was reaching out to developers outside of the US and paying them to include this SDK. And developers were bundling it, no questions asked, because they were getting paid to do so. We're still not entirely sure all of the things that they were doing with it, and we still have many unanswered questions about what the CA was being used for. So another supply chain related issue. This was about 2 years ago. As part of this was an AppCensus contract to look at contact tracing apps that were being released by public health authorities. And during the course of that, we discovered that Google is making claims that this, the Google Apple exposure notification framework is privacy protective and there's no way to re-identify people. Turns out that wasn't exactly true because the framework was logging stuff in syslog on the device, which included the rolling proximity identifiers and information about whether you tested positive. Because of the way activities work and the activity manager in Android, each screen in an app can have a unique name. It's known as an activity, and that gets logged by the activity manager. And so there are a lot of components that have access to the system logs, and we could reliably get those logs sent to Google and to demonstrate that, by crashing an app, as part of the crash reporting, the Google Play services will send reports as part of the feedback mechanism to Google. And so using Frida and getting malloc to return null is a quick way of getting any app to crash on demand, which we could then trigger one of these segments of the logs to get sent to Google to demonstrate that this is reproducible and that this sensitive data is leaving the device. But the issue is there are a lot of other components that have access to this data. So, in Google's best practices, the last paragraph here, it says, be careful when writing to on-device logs. On Android, logs are a shared resource and available to any application with the read logs permission. So only pre-installed components have the read logs permission. It's known as a system level permission. But as part of the supply chain, Android's an open platform. There are lots of suppliers. So any hardware vendor, like Samsung, LG, all of the apps that come pre-installed have the read logs permission, which means by extension, any third-party SDK bundled in those also have that permission. And so several of my colleagues did a paper on this at Oakland, I believe 2 years ago, showing all of the different third parties, including many ad tech and analytics companies, all had the access to the system logs. So we did a paper on this as well, looking at the generalizable problem of what sensitive data appears in system logs. We're going to be presenting this at Usenix later this summer. And this was a big to-do because we wanted to collect system logs from devices in the wild to try and capture a diversity of hardware configurations. Because there are a lot of different things that can impact what components are pre-installed, such as the device manufacturer, the model, the carrier, and then anyone as part of those supply chains. And so we wanted to crowdsource this, but we wanted to do it in a privacy protective way. What we did was we spent about 6+ months developing an online environment to allow us to collect these in a privacy protective manner. We used WebAssembly and Web USB so that people could plug their phones in. For those aware, you can go to the Android open source project website and flash your phone to stock firmware in the browser, and that's using Web USB. And so we basically did a similar thing where we had participants go to a website, plug their phones into a computer via USB, and then what would happen is we would scan the logs within the web browser and then send a report that just listed the data types found, like IMEI, email addresses, MAC addresses. It would send a list of the data types found without actually sending us any raw data because all of that matching was done in the browser. So we did a paper on this, and it's a pervasive problem. because there's very little control over the Android supply chain. So one example that was particularly egregious was on Nokia devices. We observed that full BLE payloads were logged by the device driver. So the Bluetooth device driver on Nokia, when it sends BLE broadcasts, the driver prints to syslog the payload of those broadcasts. This came up in the exposure notification framework issue because that's how it was taking advantage of BLE transmissions to broadcast these rolling identifiers of people around you. But even though Google fixed it at the platform level, it's not fixed on Nokia devices because for them it's the issue of the driver is logging the sensitive data, not the platform. And so it's a complicated problem. So to wrap up, what does all this mean for compliance? Well, due to third-party SDKs, apps might not be accurately disclosing their privacy behaviors. They might not be collecting data with required consent, which is increasingly common as different jurisdictions pass privacy laws that require consent for certain data collection behaviors. And all this might be happening without developers' knowledge because they're not aware of what the third-party components are actually doing. But nonetheless, they're responsible for it because they're the ones who are releasing the app. And so what to do about this? Well, I mean, right now, the main issue is developers need to do a better job of reading SDK documentation. A lot of these issues aren't due to malice, but it's due to configuration options that are buried in developer documentation that developers don't know to read. Compliance people within engineering organizations need to be aware of this issue and need to know to ask these questions about what SDKs developers are using and also be aware of how to configure those for compliance with various laws. And then also the platforms should do more. So most of the issues that I've outlined here are violations of different platform policies, but because those policies aren't proactively enforced, they remain. And then finally, test. So, I have a conflict of interest in this since this is what AppCensus does now. We do compliance testing to try and solve this problem, but I think this needs to be more widely available. Many developers aren't looking at what network traffic their apps are sending prior to releasing those apps. And so I'll leave it at that. Yeah.
Thanks, Serge. So I was not particularly trusting of technology previously, but now I'm scared to use my phone. Yeah, what is there things that an individual could be doing, should be doing, that you're doing?
I've been saying this for a while that I don't think this should be the individual's problem, right? Because I think consumers are least positioned to be able to do anything about this. Most consumers are not aware, they don't have the skills or tools to figure this stuff out. I firmly believe this is a policy problem. And I think as a consumer, what you could do is complain to your, members of Congress for, stronger privacy laws. I think that another big problem is, with COPPA, that's been the law of the land for over 20 years now, but it's only enforceable by the FTC and state AGs. And, the FTC brings an average of 1 to 2 cases a year, largely because they're under-resourced. There are a lot of very smart people there. I mean, maybe Lori can comment on this, but my, perception as somewhat of an outsider, I mean, I've consulted for them on various things, but I don't really know all the inner workings. From my vantage point, it seems like they're very conservative. They're only, bring cases against large actors that, make it worth their while. And where, there's, basically a guaranteed outcome. And they only have the resources to bring 1 or 2 of those a year. State AGs are in similar positions. And, meanwhile, there are thousands of violations. I think that what could happen to improve things is pushing more of the responsibility to the platforms and the third parties who receive the data. So every one of the third parties who has terms of service that says, don't send us kids data, they know when apps are sending them kids data because all of the apps say the name of the app. Facebook is in the business of behavioral advertising, which means knowing the demographics of, the visitors of a particular website or users of a mobile app. Like that's what, that's supposed to be a core competency. Yet at the same time, they claim, oh, we couldn't possibly tell whether or not we're being sent data from child-directed services, which is ridiculous. And, that's a problem with the law, is that in order for them to be responsible, they need to have actual knowledge and someone to be able to demonstrate that an individual at the company definitively knew that, this data came from a child. There have been some, proposals introduced in Congress to change that standard somewhat. And I think that would be an improvement, because I think it's the platforms and those receiving the data who are in, best position to do something about it. But yeah, I think consumers, there's not really anything a consumer can do.
What about very technically informed consumers? Still nothing?
I mean, when you find stuff, pass it along to regulators and the media. I think Nick was next.
So I really like the little example of the code snippet where, no, do not get any information. Okay, I'll get it from the proc. And I was wondering if that stuff was, there was probably one example where it was malicious, where somebody clearly decided to circumvent this thing and end up with that snippet of code. But I wonder if there's some sort of contagion or propagation by people just cut and pasting code that they don't understand from other sources. If that stuff had been posted on Stack Overflow, you can be sure that everybody and their dog is going to use that. So I was wondering if you have any insights as to how much code reuse of bad code leads to those violations. Like, there's no malice, it's just like pervasive incompetence.
Oh, agreed. Yes, that is certainly, there are several cases like that, and I've seen documents in Discovery that corroborate that. Yeah, and so it's hard to tell, right? How much is malice versus incompetence. But I think that like this goes back to basic software engineering concepts. Like the mythical man month, Brooks's recommendation that what is it, like a quarter of the time be spent on coding, and like the vast majority is on testing and verification, and like that's clearly not happening. Oh. Oh, yeah, Yuvraj? I guess, yeah, he's up here too.
Yes, hey, hi there. I'll also meet you later, so I have a bunch of questions, but we can chat about them. I have a question. Some of the stuff that you talked about, Serge, a pleasure to see you, is stuff that one would imagine that Google app review and process could flag and could sort of ultimately is affecting that platform. Do you have a sense that they do anything at all? And if not, why don't? And they used to have this product called checks, Google Check or something, that was also sort of in the same compliance space, if I recall correctly. It's been a while since I've talked to them. But why don't they do that? And what do they do actually right now? And there's a second part to that question is for those of us wondering, is iOS any better?
We've just started looking at iOS. And so, again, it's just lack of attention to it because it's closed source. The tools for iOS are very different because we're not maintaining a fork of the OS. Instead, we're using in-memory dynamic analysis tools to do similar things. That's a work in progress. Your first question, I have information that I can't share about that, but yes, that's a very good question. And I think the basic answer is they're not incentivized to, right? Most of these companies, they can post they post policies publicly. But beyond that, there's not a huge incentive to throw a lot of money at the problem as long as they're not being sued by, regulators and the plaintiff's bar. And so it's do just enough to avoid attention. But yeah, there are more details I can talk about.
Okay, sure.
Later. I think Roy.
Yeah, hi. Thanks for a really wonderful and an enlightening talk, even if it was kind of scary. So I have, just a personal observation. I just wanted to see what you think about it. It strikes me, two things here strike me. One of them is that the kinds of things that you have talked about are maybe well known in a fairly narrow community, like privacy, but not very well known across the population of the country. So in a nation where it seems to me that trust is at an all-time low, how do you think that widespread knowledge of the kinds of things you would talk about would influence the mood of the country?
I mean, I think, as I said to Luyo's question, like I think this is fundamentally a policy problem, and there isn't really much that individual consumers can do. But I think that raising awareness might result in, policy changes that could address a lot of these things. I mean, like at the most basic level, like just forcing, platforms to enforce the policies that they publicly post would actually do a lot of good. Many consumers believe that, when the policy is posted, that it's being actively enforced. And that's not at all the case at all. And if that were to change, that would actually solve, I think, a big part of this problem.
So I think what you're saying is that increased awareness may lead to tighter regulation.
Yeah.
Yeah. Okay. I completely agree. And again, thank you for really a lovely talk.
Yeah. Thanks for coming.
Thank you. Thanks very much for the inspiring talk. Very good collection of all these studies. Talking about the role of the different app stores, I come from Europe, from Spain, and their GDPR and policy has, I think, playing an increasing role in trying to force these app stores in having a more active role in supervising apps. And currently there are some political movements on what they call the gatekeeper. So the idea of this platform that provide access to, provide users with access to the applications so that they try to set some requirements on them. I don't know, how do you see that? Whether here in the States it's different, or do you think the political movement could go on the same direction?
I think that it would be tough getting such a policy shift passed in the US. I think that's maybe, but I'm not even convinced that's the right way of doing it. I mean, I actually think having a private right of action for many of these things would actually solve the problem. Create basically a free market for enforcement, which would also then create a market for better auditing tools as well. And so I don't think, unless, governments are willing to, increase regulatory, budgets for regulators by multiple orders of magnitude, I don't think anything like that is remotely feasible, at least not in the US. I on the kids stuff, I guess it was 2 years ago, I testified before Congress voluntarily. And said that, like, you could, I think if you give the, the FTC like a DoD sized budget, I'm not sure that would still completely solve the problem.
Set some requirements to the apps platform, to the app store, iOS or Android.
Yeah, no, I think, okay, yeah. For the platforms to do it, yeah, absolutely. I think that's where the enforcement burden should be shifted. There are legal reasons why this isn't the case, but if a brick and mortar store is selling goods that are defective and harming people, they're going to face liability. There are reasons why that's not the case for software, which by and large are services and therefore aren't. But I'm not going to get into that. But yeah, no, I think that's probably where it needs to shift, where liability needs to shift.
We're going to miss the other one because it's pretty similar to what it was just asked. The one was talking about legal liability when you use non-compliant SDKs and code snippets. Would developers or app publishers be exposed to sanctions in each and every countries in which their app is used and deployed?
I guess, it depends on the specific laws that we're talking about here. But like if there's an SDK that is clearly violating, say, COPPA or GDPR and is available to, say, children in the US or people in Europe, certainly the app developer, could be held liable. Yeah, that's the current state of the world.
last question.
Yeah, thank you for the talk. This is about the COPPA false flag.
Yeah.
Yeah, like, is there any research or in your knowledge, like, how do they even like use that kind of a flag? Like, how do they?
We're doing a paper on this right now. Yeah, so we decided to do like a COPPA revisited thing since it's been 5 years since we published that work, and both the platforms have changed policies. And now the policy shift has been that, you know, at least on Android, if you do advertising, it needs to be with these, you know, specific ad, you know, networks that support these configuration options. Right now, we're, you know, retesting apps to just look at whether they're correctly using those. You know, I pulled out a couple, you know, anecdote examples in this talk, but we're revisiting this at scale now to just look at the effects of new platform policies in the wake of the prior research.
Well, thank you very much for coming.
Yeah.